Continuing on with the notes, we were on number 3, and we're looking at the sine of theta, which would be opposite over hypotenuse, so A over C. And we want to see if that's the same as the cosine of 90 minus theta. Well, 90 minus theta, if theta at this angle is this angle, then 90 minus theta is this angle right here. So the cosine of this angle, cosine is adjacent over hypotenuse, so it would be A over C also, and they are the same thing, so that is true. On part B, the cosine of theta, cosine is adjacent over hypotenuse, so it's B over C. And the sine of 90 minus theta, well, 90 minus theta would be this angle up here, and the sine of that angle would be opposite over hypotenuse, or B over C. So again, those are the same thing. Number 4, it says find the 6 trigonometric functions using exact values. So I'm just going to really quickly list the 6 trigonometric functions, because then we're going to have them. There, I've listed all the 6 trigonometric functions, and I'm going to find the values. Well, the first thing I notice over here is I only know one side and the hypotenuse. So I need to find the other side, and I can see that since this short side is half of this long side over here, I know that this is a 30, 60, 90 triangle. So that's going to be really helpful, because then I know that the long side is 4 times the square root of 3. And so there's my third side. Now, if you didn't recognize that, you could have always used Pythagorean theorem and taken 8 squared minus 4 squared to find this value right here. You would have gotten the same answer if you simplify it down to square roots. So now sine of theta, and theta is this angle that we're looking at right here, so I'm going to circle it so you know which one I'm looking at. Sine is 4 over 8, which reduces to 1/2. Cosine is 4 square roots of 3 over 8, but the 4 and the 8 reduce to 1/2, so it's just the square root of square root of 3, that should be. Square root of 3 over 2. The tangent is opposite over adjacent, so 4 over 4 square roots of 3. The 4 and the 4 over square roots of 3, the 4 cancels out. So you just have this square root of 3 on the bottom. So I'm going to multiply the square roots of 3 top and bottom, and end up with just square roots of 3 over 3. Cosecant is the reciprocal of 1/2. Secant is the reciprocal of 2 over square roots of 3, but I can't have the square root of 3 in the denominator, so I multiply by the square root of 3, and I get 2 square roots of 3 over 3. The cotangent is the opposite of 4 over 4 square roots of 3, so 4 square roots of 3 over 3, 4's cancel out, and you end up with just the square root of 3. Number 5, we're going to let theta be the acute angle of a triangle. Again, I'm going to draw in my triangle so that I can have that picture to look at. That really helps me. So the sine of theta is opposite over the hypotenuse. So I know that side is 5 and that side is 7. And then if I do the Pythagorean theorem, I find out that this side is the 2 square roots of 6. So you go 49 minus 25, take the square root of it, is the square root of 24, which reduces to 2 square roots of 6. So now we're looking for the other 5 trigonometric functions. Sine is given already, so I have to find the other 5. I'm going to go ahead and write those in. Alright, I have them already written in, so I'm just going to find the cosine is going to be 2 square roots of 6 over 7, adjacent over hypotenuse. the tangent is going to be 5 over 2 square roots of 6, but I have to multiply top and bottom by the square root of 6, square root of 6. I'm going to write my answer down here. I get 5 square roots of 6 all over 6. All over, oh, I have this 2 times 6, which makes this bottom a 12. The cosecant is the opposite of the sine, so that's 7 over 5. The secant is the opposite of the cosine, so it's 7 over 2 square roots of 6, multiplied by square roots of 6. I end up with 7 square roots of 6 all over 2 times 6, which is 12. The cotangent is the inverse of the tangent, so I'm looking back at the original equation. Or I can look at my picture right here. The tangent was 5 over 2 square roots of 6, so it would be 2 square roots of 6 over 5. Number 5, I'm going to draw a picture. And put in my values here. So the tangent of theta is 8 over 5. Tangent is opposite over adjacent. So the 8 goes there, the 5 goes there. And if you just do Pythagorean theorem, 8 squared plus 5 squared equals c squared, you end up with square root of 89 is the hypotenuse. So now you need to list the other 5 trigonometric functions. So since the tangent is already given, I need sine, cosine, cosecant, secant, and cotangent. Sine is opposite over hypotenuse, so it's 8 over the square root of 89, multiplied by the square root of 89, and we end up with 8 square roots of 89 all over 89. And you can just leave your answer as a fraction. That's okay. Cosine is the same thing, only with a 5. So you end up with 5 square roots of 89 over 89. The cosecant is the inverse of the sine. So it's the square root of 89 over 8. The secant is the inverse of the cosine, which would be the square root of 89 over 5. And the cotangent is the inverse of the tangent, which was just 5 over 8. Number 6, we are just going to find the value of x using known trigonometric functions. So notice this is 30 degrees, and I'm looking for x here. So I just have to think to myself, okay, what trig function uses this side that is adjacent and the hypotenuse, and that is the cosine. So I'm going to find the cosine. Sorry, handwriting is terrible here. The cosine of 30 degrees is equal to x over 8. Now what I'm trying to do is solve for x. I'm going to multiply both sides by 8. So I end up with x is equal to 8 times the cosine of 30. So at this point you grab a calculator. The first thing to check is to make sure that your calculator is in degree mode. And how you can check on that is if you hit the mode key, and it lists a bunch of things: normal, scientific, engineering, blah, blah, blah. If you go down to the third line, it says radians or degrees. You want the degree to be highlighted. So arrow over so the degree is highlighted, click enter, because you want your calculator to be in degrees. And when you do that, you plug it in the calculator and you find that x is equal to approximately 6.93. Same thing for this one right here. 45 degrees, we're looking at the adjacent. Okay, the next example, we are looking for x this time over here, and we have this 30-degree angle there. So we have to think what trig function uses the opposite leg and the hypotenuse, and that is the sine. So I'm going to take the sine of 30 equals the opposite divided by the hypotenuse. Again, I'm solving for x. I'm going to multiply both sides by 13. And I grab a calculator and I put 13 times the sine of 30 in my calculator that's in degree mode, and I get approximately 6.5. We can round it to the nearest 10th, the nearest hundredth. We're not going to be too picky about that. Number 7a, we are looking for all the missing sides, or in other words, to solve the triangle. To solve the triangle means find all the angles. Right now we know that angle's 28, that angle's 90, so maybe the first thing I would do is find this angle right here, and I would take 90 minus 28, and I would get 62 degrees. So there, I found all the angles. Now I know this side is 15, so I have to find both of these sides right here. And it doesn't really matter which one you do first. Let's look at C. So if I want to use 28 and C and B, I know that's a cosine relationship. So I would write the cosine of 28 degrees is equal to the adjacent side, which is 15, over C. And this time I have to multiply both sides by a C, but then I want to divide both sides by the cosine of 28. So I end up with C is equal to 15 divided by the cosine of 28. So I grab a calculator and I just put that in. What is 15 divided by the cosine of 28? And the answer is, you should get, is approximately 17. And that makes sense. The hypotenuse is always going to be bigger than one of the legs. Now we just need to find A, and you could do using trig functions, or I recognize that we know this is 17 and this leg is 15. I like the Pythagorean theorem. So I know that A is the square root of 17 squared minus 15 squared. So I'm just going to, because that looks, pretty simple to me, I put that in my calculator, and I get A is approximately 8 units. So there, I've solved the triangle. I found all 5 or 6 pieces, the 3 sides and the 3 angles. 7 part B, I need to draw a triangle first so that I can figure out what I'm looking for here. We almost always write the 2 legs A, B, and C, so if it tells me C is 5, I know that's the hypotenuse. B is opposite side B, so this would be angle B, or point B. This would be A, and then C is the right angle. Well, if angle B is 45 degrees, then I know that angle A is also 45 degrees. So I have a 45-45 right triangle here. And I am just going to use the sine of 45 is equal to, so sine is opposite over hypotenuse. So I would write the sine of 45 degrees. Sorry, I'm writing all over the place there. Is equal to A over 5. And when you solve that, you get A is equal to 5 times the sine of 45 degrees. And you just plug that in your calculator, and you find out that A is 3.5.